Now let's try and understand what is ABAC, which is Attribute Based Access Control. But before that, let's talk about RBAC. I know I have already told you what is the role, and RBAC or Role Based Access Control provides access to resources or information based on users' roles. Hence, your role defines your access to the resources. Let's see this. This is an admin. This is the admin user, which based on the role of admin has full responsibility to maintain and provide access. I hope you agree to this point. So this is the admin user, and based on his role or his or her role has full responsibility to maintain and provide access. Next, we have the architect, which has admin access to account A, B, and C. We also have the ops team that has read-write access to account A, B, and we have the account team which has access to accounts D and E. And these are based on the role itself. And then we have the dev team or the developer team, which has read-only access to accounts A, B, and C. And this is what role-based access looks like. And these are the roles. Let's suppose we have admin role, we have architect role, we have accounts role, we have people who are under the role of ops team, we have developers. And based on that, they have been provided access to these accounts. And the type of access is also defined based on the role that they have. And I want to tell you here one thing that you will be interested to know, that the traditional authorization model used in IAM is also role-based access control. Yes, where RBAC defines permissions based on the person's job function known outside of AWS as a role. And within AWS, a role usually refers to an IAM role, which is an identity in IAM that you can assume. When I say we assume role, let's see how that looks. We can see the admin actually assigns the users with the appropriate role like SRE, architect, or developer, etc. And we have the users here with their assigned role, based on which the roles are defined and the required authority level and permission is granted based on the specified role. So you define the role and then the permissions are authorized for specific roles. The admin that you see here is having full access, and based on his or her role, the permissions are provisioned. And similarly, we have the same for other roles, and these are not just defined for users. They can also be for user groups like a group of admin or a group of developer. In IAM also, if you want RBAC, we can implement RBAC by creating different policies for different job functions. So yes, we can create RBAC implementation also in IAM using different policies for different job functions or by creating them. But you might ask me, if everything in RBAC is sunshine and rainbows, what's the problem here? The disadvantage of using the traditional RBAC model is that when employees add new resources, you must update policies to allow access to those resources. Did you understand what I said? Okay, if you didn't, then let me explain this. Let's suppose these three are projects and we create an IAM role for each of these projects. Then we attach policies to each IAM role to define the resources that anyone allowed to assume the role can access. Remember, users can be assigned to one or more roles. Let's suppose you imagine the third project that we have here needs a resource update, like we need S3 service for our reporting tool. So you have been working on the application, and next you thought of incorporating a reporting tool, and then you thought of using S3 as a service. So in that case, we need to update policies that are attached to this third project. Otherwise, the users and programs that assume the role will not have access to the buckets. Yes. And after listening to this, you might say, can we use attributes to control access via IAM? Okay, sure. If you want attribute-based access control, let's understand that. Now, what is ABAC? That is attribute-based access control. Just like RBAC is based on roles, ABAC is based on attributes. Attribute-based access control is an authorization strategy that defines permissions based on attributes. And what are attributes? In AWS, these attributes are called tags. Yes, attributes are also called as tags. And how do we do that? Yes, by attaching tags to IAM resources, including IAM entities or identities that are users or roles, and to AWS resources. Hence, we are attaching tags, in other terms, attributes to the IAM entities and to the AWS resources. And why is it better than RBAC? Is because ABAC policies can be designed to allow operation when the principals tag matches the resource tag. And if your application or project is evolving rapidly, we need to just attach the access tags to the resources and they will be available to the users. Now enough of talking, let's see this example here. We have 3 projects. We have tags attached to these entities: access rocket, the second tag is access weather, and the third project tag is access healthcare. And these symbols that you see are basically the ones that are having the attributes. That is why it is denoting this. So this is for rocket, this is for the weather, and this is for the healthcare. And that is how we are defining the tags also. And the policies attached will be based on 3 types of attributes. So it could be the user attributes, it could be the environmental attributes, or it could also be the resource attributes. And the resources will be coupled with the access tags, and which will allow users to use the same tags to make use of them. So as you can see here, we have the rocket tag, weather tag, and the healthcare tag for the S3 bucket. And the users which have the same tag, or the resources which have the same tag, or the entities that have the same tag, will be able to access the resources. So we have a resource called S3 bucket here, and they will be able to make use of that. The project will also be able to make use of that resource. And now what will happen if suppose we are trying to evolve our application, just like we discussed in RBAC. So if we want to do that, and let's suppose our application is evolving and it wants to use EC2, we can just add the resource with the same resource tag: rocket, weather, healthcare. And as the resources will be coupled with the access tags, which will allow users to use the same tags to make use of them. And that is the beauty of using attribute-based access control. I hope you got the point here. Let's move on. Now if we see the same example for RBAC, you have policies attached to the role based on your job function. So these policies are already attached based on the job function or the application that you're working on. And the policy that we make use of has a permission set to access the resources, for example, S3. Based on the policy we have, we are able to make use of S3. And now if our application or project evolves and needs EC2, we have to update the policies. And in order for it to be effectively applied across the principles, we have to update the policy. And that's the major difference between RBAC and attribute-based access control. And I believe by now, and I really hope you got the idea of how different RBAC and ABAC are. One on the left-hand side is an authorization strategy that defines permissions based on attributes. In AWS, these attributes are called tags. Thus, the name attribute-based access control. And on the right-hand side, we have RBAC, which defines permissions based on the job function of a person, known outside of AWS as roles. And that is why the name role-based access control. Now let's talk more about the benefits and advantages of using ABAC. First, ABAC permission scales with innovation. That's a very good and very heavyweight benefit. With the growing scale of projects or applications, we can scale our policies without intervention from the admin. That's a chill way of doing it. Because if any resource have to be added, the developer itself can create the resources with the proper tags. Like if you are working on a project, you can create the resources with the proper tags, and the policy would definitely allow access or permission for the resources to be consumed. Simple way, isn't it? The second one we have here is ABAC requires fewer policies. Yes, because unlike RBAC, we don't have to create different policies for different job roles or function. So fewer policies, thank God. Next, using ABAC, the teams can change and grow quickly. So let's suppose you were a part of the project Rocket and you are changing the team. You itself are changing the team. The project is not changing, don't worry. And you are basically going to join another project and you're going to work for another project. So the admin can just remove or update your tag to the new project. Simple. Similarly, if you need to add users, you can attach the policy to them or attach the tags to them appropriately, and then they will have the access. Next, granular permissions are possible using ABAC. This is because unlike RBAC, you can actually implement least access privilege principles by creating a policy with permissions to just perform the task. But this is good in a way because permission scaling is rapid in attribute-based access control. And last but not the least, use employee attributes from your corporate directory with ABAC. This is a very good benefit, I tell you. When we use session tags with SAML, we can pass these session tags that we have to AWS, and by using these attributes, we can provide access using attribute-based access control, like project or team or business unit or even cost center. So if you belong to a particular team or a project or a business unit or even a cost center, so these will have session tags. So if your user has a session tag based on the user attributes, we can pass those session tags to AWS, and based on that, we can provide you access. Now that you've understood what is user, user group, role, policy, access management, let's see how do we delegate access from one AWS account to another without creating an IAM user in another account. Now let's understand this. How can we delegate access across AWS accounts using IAM roles? So as it is mentioned here, you can share resources in one account with users in different account. So you can share the resources in your account with users in different account. And we can do this by setting up cross-account access. And in this way, you don't have to create individual IAM users in each account. That's a good thing. Let's suppose you are a developer in the developer account and you want to access an S3 bucket in the production account. And you don't want other teams from your account, like the testing team, to be able to have the same rights. So what we are trying to do here, we are just trying to give the developer team to have access to the S3 buckets in the production account, not the testing team. So how can we achieve this? And this can be achieved with 3 steps. Let me tell you those 3 steps. First step is to create a role in the production account. The important thing here is to establish a trust relationship between the prod account and the dev account. So the first step, we need to create an IAM role called update app. You can use the name of your choice. It's not a keyword. So we have to first create an IAM role. And in that update app role, we need to define the development account as the trusted entity and specify the permission policy that will allow trusted users to update the S3 bucket at production. And once we are done with the trust relationship and the role creation, the second step is to grant access to the role. Here we will update the IAM role with a deny effect for the tester group for the update app role, so that only the dev team has access. You might ask me why to explicitly define a deny. If we don't add also, it should work because there is the implicit deny. But let's suppose your testing group has an admin or a power user privilege. In that case, if we don't add, it will not work. We need to add a deny rule explicitly. Now let's come back to the last part. Step number 3, which is test access by switching the roles. Once the roles are set up, when both dev team and the testing team tries to access the role or assume the role, let's see what happens. Yes, as the policy determines, allow for dev team, the dev team only will have the access. Hence, with these 3 steps, we can delegate access across AWS account using IAM roles. But this is just the image. Let's see how the policy actually looks like. Let's see the policies and trying to understand how it works. The first thing that you need to understand is that you don't need to create IAM users in the prod account for the other accounts to make use of. That's clear because we are just delegating access, because our purpose is to delegate access from dev to prod for the same users, but just by assuming the role that we create. And the first and foremost thing for us is to create the IAM role on prod and establish a trust relationship with the dev account. Let's see the policy here that is associated with the role, that is update app role. So if you see here, we have the version 2012-10-17. This is standard, and this statement has multiple inner blocks within it. So this is the first statement, this is the second statement, and this is the third statement. And the effect is allow for the first one, and the action is S3 list all my buckets, and the resource is star. So the first operation allows all the list bucket operations. And then we have the second policy where the effect is allow, but the action is list bucket, get bucket location for the resource production app. So imagine production app to be the bucket name of the S3 bucket that the dev account developers want to make use of. And the third one is the effect equal to allow, get object, put object, delete objects are the action. And it is for the object level access for production app bucket. And you already know why we have separated into different blocks and not written it like test star or production app star, because of the complexity and the granularity of the permissions. And once you have created the role here, at the last step when you're creating the role, you have to choose at the last step as the role type to be an AWS account. And you have to add the dev account ID there in the last step. And that's how we create the trust relationship for that particular role that we are going to define here. And now we have created the role in the production account. And the next thing that we have to do is we have to create a policy in the dev account. And that will be a assume role policy. This is used to modify the developer user group to allow them to switch to the update app role, which is created in prod. So this portion is for the dev account, and this policy states that effect is allow and the action is STS assume role. So using STS, we are able to assume the role, and on what? And thus the resource here will be ARN AWS IAM production account ID. This is the production account ID colon role, that is the resource type. And what is the role ID? That is update app. So this is the update app role, and that is what we are going to assume the role as. And remember, this is created in the production, this is created in the dev account. And one more thing that we had in mind, that was to restrict access of the tester user group. And here to deny the access, what we can do is we can write the same policy, but just we will give the effect equal to deny, so that they should not be able to assume the role of that particular update app in the production account. And this policy will be attached to the tester user group, so that they will not be allowed to assume or set action of STS assume role on the resource, that is production account colon role / resource ID is update app. So I hope you got the point on how we have created the role in the production and how we have maintained the policies at the dev side. And this will actually help you to assume the role and to make use of the resources in the product. And now let's see how we can create and attach customer managed policy. Remember these lines very carefully. First, by default, IAM users don't have permissions to do anything. So by default, IAM user does not have any permission to do anything. And when you attach a policy to the user actually inherits all of the access permissions that are associated with that policy. Once the policy is attached, you can sign in as the user and test the policy. So this is basically the idea. So by default, IAM user does not have a permission. And if you attach a policy to the user will actually inherit all the access permissions that are associated with the policy. So once the policy is attached, you can then sign in as the user and test the policy, whether you are able to access the resource or not. Now let's see an example here on how we can allow any user to access AWS Management Console with read-only permissions. The first step is we create the policy. Here we create the customer managed policy that allows any attached user to sign in to the console. Just that, simple. Once we have created the policy, the second step is to attach the policy. As I have already told you, when you attach a policy to the user will inherit all of the access permissions that are associated with that policy. Now, we created the policy and we have already attached it to the user as well. Hence, the last step for us is to test the access. So once the policy is attached, the user can sign in as the IAM user and test the policy. Now, let's see the actual policy. Here you can see we have allow effect and the resource is star, and the action that are provided here are generate credential report, IAM get star, and IAM list star. And with these three policies, the user will be able to log into AWS console with read-only permissions, because it will not be able to create any policy or update any policy. It can just list and read the policies that we have. And it will be able to log in and view the policy and the permissions itself, but not update them or create them. And it will also be able to generate the credential report. So this is one of the ways we can actually create and attach the customer managed policy to a user. And finally, we have reached the point where we will discuss a feature of IAM that has made life easier when it comes to managing access and policy refinement. And that is AWS IAM Access Analyzer. The biggest concern and the biggest problem with IAM is its security. And that is the reason why I kept this topic for the last. And I repeat my words again. The biggest problem and the biggest concern with IAM is its security. Let's read this statement and let's try and understand this. AWS IAM Access Analyzer helps you identify the resources in your organization and accounts, such as Amazon S3 buckets or IAM roles, shared with an external entity. This lets you identify unintended access to your resources and data, which is a security risk. Now you will have two doubts after listening to what I just said. What is an external entity? And second, what kind of security risks? The first point is an external entity can be another AWS account. It could be a root user, an IAM user, or a role. It could be a federated user. It could be an Amazon service or AWS service, or it could be an anonymous user, or it could be other entities that you can use to create a filter. And the security risk is considering the fact that the policies attached to an external entity could still be applicable or granted even though they don't need it any longer. So you might ask me, what could be the use case? A simple example would be, let's suppose you wrote a batch script and you wanted to access the production S3 bucket. And once you're done, you no longer need access to the S3 bucket. So once you're done with your work, you no longer need the access. Then how are you going to make sure the infrastructure remains secure if your policy remains intact even though you no longer need it? Then it would obviously violate the principle of least privilege. Having said that, you will still ask me, what is Access Analyzer? IAM Access Analyzer is a service that helps you identify the resources in your organization and accounts, such as Amazon S3 buckets or IAM roles, shared with an external entity. Now you will tell me, okay, but I can manually do the same thing. Why do I need IAM Access Analyzer? I'll sit as an admin and constantly check all the policies and make sure we are safe. But one thing you have to understand is that a security breach or security risk doesn't wait for your technical wokeness. Making sure you have a tool that can help you counter this is a far better solution than your self-righteous work ethic. I know it sounds harsh, but it is very serious. Now let's see what happens when we create an access analyzer for your account. Here, for each instance of the resource shared outside of the account, Access Analyzer generates a finding. It then shares all the information about access and the external principal granted to it. You get the information about who has access to your instance and its permissions. So that is the information that you get. And based on that, you determine whether the access is appropriate and safe, or if the access is unintended and are you at a security risk. And remember this very carefully. When you enable Access Analyzer in IAM, you create an analyzer for your entire organization or your account. The organization or account you choose is known as the zone of trust for your analyzer. This account that you enable Access Analyzer is called your zone of trust. Remember this, zone of trust. So when you enable Access Analyzer, you create an analyzer for your entire organization or your account, and the organization or account you choose is known as the zone of trust. The analyzer monitors all of the supported resources within your zone of trust, and any access to resources by principals within your zone of trust is considered trusted. That's what I wanted to tell you. And Access Analyzer can help you with these two things. First is validating policies. Here you can validate your policies using AWS Access Analyzer policy check, and Access Analyzer validates your policy against IAM policy grammar and the best practices. Second is generating policies. Here AWS IAM Access Analyzer analyzes your AWS CloudTrail logs. Understand this, it analyzes your CloudTrail logs to identify actions and services that have been used by an IAM entity. That could be a user or a role within your specified date range. It then generates an IAM policy that is based on that access activity. And when analyzing the policies, if the Access Analyzer identifies one that grants access to an external principal that isn't within your zone of trust, it generates a finding. And based on that finding, you can keep track of what is safe and what is the security risk, as I already explained you in the diagram above. So I hope you got the point. Let's move on. Here Access Analyzer analyzes the resource-based policies that are applied to AWS regions or resources in the region where you have enabled Access Analyzer. And remember that only resource-based policies are analyzed. Remember this point very carefully. AWS IAM Access Analyzer analyzes the resource-based policies. that are applied to AWS resources in the region where you enabled Access Analyzer. And remember that only resource-based policies are analyzed. So you might be thinking like, what are the services that could be used here or supported here? So here we have a list of resource types that are actually supported. So the first one is Amazon Simple Storage Service Bucket, that is the S3 buckets. We have AWS Identity and Access Management roles. We have AWS Key Management Service or KMS. We have Lambda functions and layers and SQS queues and AWS Secret Manager secrets. So these are the supported resource types. And I hope you got the point here. And thanks everyone for joining in for today's session of AWS. I hope you got some of the information that you wanted. And if you haven't subscribed already, then please do so. Please comment and like the video. And that really helps me a lot and helps the channel grow and is a really motivating factor for me. So please make sure that you subscribe. It really takes a lot of work and a lot of hard work to actually bring in these videos. So please make sure that you support the channel by subscribing and liking the video. So I'll meet you in the next session of AWS. Stay safe, stay healthy. It's Pythoholic signing off.